So we're in the chapter that's covering fertilizers, and we're in the section that is discussing inorganic commercial fertilizers. So fertilizers that are produced apart from, well, let's call them natural means, or nutrients that are supplied by industrial processes of both mining and manufacture. Depending on which nutrient we're talking about, especially with nitrogen, phosphorus, and potassium, the three that you see here. Phosphorus and potassium are potassium especially is a mined product. Phosphorus also is a mined product, and we do various forms of purification of the mined product to put on our fields. Nitrogen, however, is not commonly mined. It's commonly manufactured through a process called the Haber-Bosch process. And that takes nitrogen from the air and converts it, we've discussed this a little bit before, and converts it into a usable form of nitrogen. So either nitrate or ammonium or ammonia. So that process really got underway around World War II, is when this process began to be very important. Since then, and only since then, do we get this graph that looks like this. So you can see the what happens with nitrogen as we move forward in time. So this is world fertilizer usage, and you can see here we have the nutrient in metric tons, and again the year on the x-axis. But you can see for nitrogen we've really begin to use a huge amount of nitrogen compared to what we at one time used. So you can see the comparison here, how much we've increased, and then this is just in the last 50 years, right? So from 1960 to 2010. So in the last 50 years, which isn't very long, we have begun to use a huge amount of nitrogen fertilizers. And so when we talk about fertilizer use and fertilizer contamination and the Green Revolution and high yielding agriculture, it has to be viewed in light of this capability that we now have to do this process, and then apply that process to agricultural productions, because this process is useful in other ways too. And that should be, let me erase this real quick. This should be NH3. Okay, so that's ammonium, and ammonium is what we typically make in the Haber-Bosch process. So this is really kind of both a production factor. So this accounts for the increase in production that we see. This area right here is the increase in yield that we have. A big portion of the increase in yield of corn and wheat, soybean. Well, not soybeans necessarily, because soybeans are legumes and they can create their own nitrogen in symbiosis. We discovered that in the last chapter. So a large part of the yields of crops that don't do that nitrogen is responsible for this, and this huge worldwide increase in nitrogen is responsible for those kinds of increases of yield. So it's important to kind of set this in context of where we are in the historical scheme of things, that only in the past 50 years have we really begun to understand the mechanics of nitrogen and begun to really use nitrogen in a huge, really huge way, in a concentrated way. We'll discover the different kinds of concentrations of materials that you can put on your fields in the form of nitrogen fertilizers here in just a bit.